Hi, this is Haishao Wang, and today we are going to talk about the alien dictionary. And given the list of the words that are sorted in lexicographically increased order, and we are supposed to return uh, uh, a string of the unique letters in new alien languages that sorted in order. And so let's just go through quick examples. For example, in the example one, and we just suppose compare these two of the words, which is WRT and WRF, and we try to find first characteristic that differs from each other's, because this part is just the same, and the only different characters is like this. So we can infer from this. We can infer that T is less than F in the alien dictionaries. So actually, we can just suppose there is a node which is T, and there's a other node that is contains F, and because T is less than F, so there is actually edge from the T and to F. And so basically we just compare each two words in order of the words list, and just just construct a graph that based just like this example here. And this is a typical topological problems, and we can just start BFS as the starting node is like the node that has 0 inbound edges. And for example here, for example, T is also less than G, I guess, and F is also less than G. And here we just start from the T. So here the T is the most small characters in Asian dictionary, and then it's F, and then it's G, and this is basically the idea behind these problems. So let's just code it up. So because we want to try to start BFS from the starting node that has 0 integrates, so we just create the one forward inwards and for C inward gray. This is just to initialize the integrates. And this is just a graph that we try to build. Because we try to compare the words from, for example, these two, and also these two, and these two, and these two. So this should be -1. Corner cases. W1, W2 is equal to and the corner cases is that if word 1 is greater than word 2 and is equal to W2. And this is have a contradictions with a word provided in the prompt, so we just return the empty string. And if not, we just start to find the first characteristic that they are differs from each other. if the k is just equal to length of the w1, which means that we go through the array characters in word 1 and word 2, and we didn't find the different characters, which is just like for example, A, B, C, and A, B, C, D. And we just go through the array characters in word 1, and we did not find the characters. And this is meaningless, so it cannot bring any information. So we can just continue our loop. And if not, so there's address that from the W word 1 at index of k, and because 2k should be +1 because there is an inbound edges, so we should update it integrates by +1. If we just go through the key and values, key value pairs in the integrate, and if the frequencies of the characters is just equal to 0, which means that we should start from those kind of characters. So Q just append F to append C, and just start our for loop. Q and size is just equal to Q and current string. And we should update it is the next characters integrates, because we already visited the card. So it should be -1, and if the integrate is equal to 0, we just continue to append it to our queue. And if the length of the result is less than integrate, which means that there are some characters in the integrates that are unvisited. So it must be some loops in the result in the graph. So we just return and else, which is return is. I think it's pretty much about these problems. Yeah. Thanks for watching.